Well, it is 1 o'clock. I'd like to welcome everyone to our session today on adding nutritional value through upcycling, a tale of protein and fiber. We have our panelists here as well. I'll introduce you to you in just a minute. My name is Beata Lloyd. I'm president of AgriFiber. AgriFiber is based in Mundelein, Illinois, and our mission is to develop fully customizable, sustainable specialty ingredients that deliver functional benefits, improve nutrition content in a sustainable way, and enhance flavor and texture of food products. Food and food ingredients that were once thought of as waste or thought to be low quality are considered useful and are now seen as really relevant and nutritious. And you will learn more about that in today's session. And increasing population economic pressures and shifts in attitudes towards certain foods have paved the way for new opportunities to upcycle food ingredients. New technologies that are emerging have meant that emerging ingredients are now as not low quality, but in fact, fully functional and nutritious with minimal processing. Formulating foods for health, considering this growing trend of upcycled ingredients available to us, is more timely now than ever. So as we leap in the future, this webinar serves as a guide to food technologists and manufacturers to get really creative with new sources of fiber and protein when considering consumer needs and wants in this growing trend. So I'd like to introduce our panelists, Mr. Turner Wyatt, who's co-founder and CEO of a non-for-profit trade association whose mission is to reduce food waste by growing the upcycled food economy. We have Dr. Stu Phillips, who is professor and Canadian chair of the Department of Kinesiology at McMaster University, and he will be speaking today about dietary proteins to maintain muscle health and to discussing this place for upcycled protein in that. Edward Deehan, Dr. Deehan is senior R&D and scientific affairs scientist with AgriFiber, and he will be speaking about adding nutrition value through upcycling, the fiber side of the story. I'm looking forward today to the event and look forward to your participation as well. At the end of the session, towards the end, we will have a Q&A. So please, if you can, hold your questions to the end. We will address them though. So thank you again for registering and for joining us. Turner, I'll start with you. I'll hand this to you. Thank you.
Thanks, Beata. Yeah, nice to be here. Thanks so much for having me. I think I'm the only person on this panel today that doesn't have a PhD or the title doctor in their title. So we're just going to get me out of the way. I'm going to get out of the way so that the smart people can do their thing. So I'm honored to be on this panel with some really talented individuals that are doing really great things to prevent food waste. Why is it important to prevent food waste? Well, for one thing, it's the most important solution to climate change. Project Drawdown ranks it as the #1 solution to prevent global warming of more than 2 degrees centigrade. And it's also important because there's $1 trillion worth of food that's wasted every year, which means as food companies or as business people, there's a huge incentive to prevent food waste by commercializing that $1 trillion worth of otherwise wasted food. And the upcycled industry is the first consumer product driven industry that presents the opportunity to empower millions of consumers all over the world to activate this solution, to prevent food waste with the products they buy. And at Upcycled Food Association, we are working with hundreds of businesses all around the world to develop a unified message that helps to educate millions of consumers at scale so that demand for upcycled products increases and accelerates, and the rest of the upcycled supply chain can provide a great capacity for food waste prevention throughout different links on the food supply chain. And so I'm going to talk for just a couple minutes to set the stage on what is the problem, what's the solution, and what's the opportunity. So like I said, 1 billion tons of food goes to waste every year, and it's worth about $1 trillion. And there's a group of businesses, some of which are represented in this call. I'm seeing some names that I recognize, and some are on this panel, who have identified unique and creative ways to take some of that 1 billion tons per year and unlock the value therein. Here's an example, something that I say all the time. When you grow a banana, you don't get the flesh of the banana, the fruit, and get the peel for free. It takes energy to create the whole banana tree and the bark and the roots and the peel. And so if you as a producer are putting money in and resources into creating the whole banana, doesn't it make sense to get the whole thing out? As business people, we're supposed to be working to reduce loss. And upcycled products give us the opportunity to unlock the value that's in something like the banana peel. But are consumers really going to buy this? Well, early research and continued research really has shown us that generally, yes. A number of studies done over the past couple of years have showed us that most consumers want to buy more upcycled products. But there's a limiting factor, and that's most consumers don't know what upcycled products are. So about 80% of consumers would purchase upcycled products, but less than 10% know what they are. So that's a problem. How do we educate all these people all around the world to create a whole movement so that one day consumers can fill their whole grocery cart with nothing but products that help to prevent food waste? That's a really exciting opportunity. But how do we do that? Well, no one business has, even big businesses like Dole and Del Monte and Mondelez and US Foods, all businesses that are a part of the Upcycled Food Association membership network, even they don't have the marketing budgets to educate millions of consumers ubiquitously across the world. But when hundreds of businesses work together, then it becomes possible. If we are all using the same messaging strategy and aligning, then people see an upcycled product over here and it's being messaged in the same way as an upcycled product in this other aisle over here. And they start to draw the link between the two, and we can start to influence consumers' purchase behavior, because we know if they just know what upcycled products are, they're much more likely to purchase them. And so how are we doing that? Well, one way that we're really excited about, because we just launched it a couple of weeks ago, is the world's first third-party verified product and ingredient certification for upcycled products and ingredients. So how does this work? Well, ingredient companies like AgriFiber and the CPG companies, the hundreds of CPG companies that are within our membership, can apply for certification to align their product with the Upcycled certified logo and brand and messaging strategy. So a certified upcycled product, upcycled certified product is going to have a very attractive logo on pack that shows consumers, look, this is an upcycled product. When you buy this product, you're helping to prevent food waste. When you buy this product, you're contributing to that best solution to climate change. And we've done some tests on the logo. And here's a few things that we know. Well, more than 80% of consumers want to see a logo on the front of pack of an upcycled product. So that's important. But 97% of consumers think more positively about grocery stores that carry upcycled products. So that's important, because by having more of these logos around, we're kind of giving retailers credit for something that consumers want to see them doing, carrying upcycled products. And we also tested the actual logo, which you can read about on our website and see. And even before anyone had ever seen this logo, it's brand new. We just launched the program, and the study was done a couple of months before the program was launched. So nobody had seen this logo. And it already tested better than some logos that were invested by big companies and had been around for years. And more than half of consumers had increased intent to buy for the same product with the logo. So that's a really amazing value proposition. And all these tools, the consumer education that we're doing, everything, when you put it all together, is helping to accelerate the growth of the upcycled food economy, not just for human food, but for pet food and dietary supplements and cosmetics and other things too. And so whereas before, a few years ago, we thought that this industry had about a 5% compound annual growth rate, we think with all of these different methods that we're taking on, we're going to accelerate that to at least double. So the time is now to invest in food waste, especially in upcycled food, because it's time to empower millions of people around the world to prevent food waste and participate in the best solution to climate change with the products they buy. And so with that, that's the framing that I'm going to do today. And I'm excited now to pass it off to Dr. Stuart Phillips.
Thank you, Turner. This is great.
How am I doing? Good? All right, great. So first of all, I'd just like to thank Beata and Turner and AgriFiber for giving me the opportunity to speak today. I might be the one thing that doesn't look a lot like the other, and that I'm going to talk more about protein, how it's managed, and why we should care about it. And so not about fiber, although right at the end, I'm going to give a little bit of a fiber pitch as well. So before we get started, I think it's important that I just make a few funding and disclosures. These are the agencies in Canada that support the work that we do, and some agencies for whom I've received consulting fees for work on muscle and protein. So when we talk about something called protein turnover, I like to explain to people that all proteins in our body are like a brick wall. And the brick wall is constantly being both made and dismantled at the same time. This is a concept of putting the building blocks of protein, which are amino acids, into the wall on one hand, and then having them pulled out on the other hand. And it's almost like a constant maintenance process to make the wall function as well as we can. When we represent this schematically, the proteins or amino acids, going into a muscle are represented by the process of muscle protein synthesis. And the proteins leaving muscle are represented by the processes of muscle protein breakdown. And I've highlighted these for you here with MPS as the yellow and MPB being in red. So when we wake up in the morning and we eat breakfast, we get a marked stimulation of muscle protein synthesis, or bricks going into the wall, and we get a little suppression in the rate of muscle protein breakdown. This green area then represents a small amount of muscle protein that's going to be accrued, if you like, within the muscle itself. But you can see that this is a short-lived process and it's beginning to decline. And in fact, it reaches a nadir, if you like, around lunchtime. And we have this gray area until we eat our lunch that represents an area of loss of muscle protein. But then we get a stimulation followed by a loss. We eat our dinner and we get a further stimulation. What's not shown on this graph would be a large gray bubble at the end of the day. That is when you're sleeping. You're not eating any protein containing foods. So how do things change then if we add exercise? This is the condition that we use to try and understand how we can improve the muscle mass and function of younger individuals, maybe for an athletic endeavor, or for older individuals to mitigate the loss of muscle they might experience during aging. Quite simply, exercise is sort of like the magic bullet. It makes everything better in that every time now when you eat protein, you get a greater anabolic response and you get a smaller catabolic response. So in this situation, you can see that the green areas exceed the gray areas, and over time, that's what's creating muscle growth, or over time, it's slowing the loss of muscle protein. This is, however, in reality, what most people do. They eat a small amount of protein at breakfast, a medium amount at lunch, and a large amount at dinner. And the protein dose at which we are maximally stimulating protein synthesis differs according to age. So an experiment that I'll show you here, done by a former PhD student of mine, Dan Moore, highlights that when we look at the force generating proteins within muscle and their rates of synthesis, it's maximally stimulated at a dose of about 0.24 grams of protein per kilo, and at a dose that's almost 70% greater in older individuals. So these guys were about 22, these men were about 72, and you can see they require 70% more protein to stimulate a rate of protein synthesis within their muscle. Interestingly enough, however, both groups reached the same level. It wouldn't make much sense for me to recommend more protein for older people if they weren't able to get to the same level of protein stimulation. So what we notice with aging is what we call an anabolic resistance. We get a reduced level of stimulation of muscle protein synthesis with each protein containing meal. And it's this evidence and the data that we showed about the plateau being the same, but for more protein, that is the fundamental basis of recommendations for more protein consumption in older individuals. The RDA sits at 0.8. I would have no problems if instead of this saying the recommended dietary allowance, it was the minimal protein intake, because it certainly is the protein intake that prevents deficiency, but more optimal functioning can be maintained at intakes closer to 1 or 1.2 grams per kilo, and higher intakes in conditions of acute or chronic disease or severe injury, illness, or marked malnutrition. So just to reiterate, older people not only need, but could benefit from more protein. And need is different than having an optimal stimulation. I'm going to use this paper, which was written by Daniel Traylor, a former postdoc in my lab, to make one point. And people constantly hear this in the news, is that everybody's getting enough protein. And that answer is true if you use the wrong yardstick, which is the RDA. And I'll just make the point here by showing you that we've replotted as a percentile men over the age of 71 and women over the age of 71 using the current recommended dietary allowance and the estimated average requirement here. And you can see that almost 75% of men and a greater proportion, 75% of women and a greater proportion of men are above this line. So it's really not an issue. However, if you use the current or the proposed RDA and the estimated average requirement, you can see that it's probably not until the 80th percentile or maybe even higher in older women that you begin to get people that are eating enough protein. So quite simply, everybody is not eating enough protein because you're using the wrong measure. So the protein threshold then that I showed you earlier in the Moore paper is particularly important. And this figure drawn for me by Sarah Oikawa, former PhD student of mine, shows that concept. So there's the breakfast meal, there's the lunchtime meal, there's the dinner time meal, and Sarah's even incorporated a small pre-bedtime snack, and then this is when these folks are sleeping. When we look at the per meal protein content, if you're a younger person, you hit this twice a day, no problem at all. But if you're an older person, you only hit it one time per day. So only one meal provides an optimal stimulation of muscle protein synthesis. Again, highlighting that it's important that older people consume either more or higher quality protein. What we've known now for several years is that one single amino acid that is an essential amino acid known as leucine is the key amino acid that triggers protein synthesis, particularly in muscle, but also in other tissues throughout our body. The quality of proteins is based on their digestibility and as well as their essential amino acid content. But I would put it to you that it's the amino acid leucine that is probably more important than any other amino acid as we get older. So it is a branched chain amino acid. It's one of three. There are isoleucine and valine are its two partners. The level of leucine, probably not in the blood, as this graph might suggest, but in the muscle is definitely very important. There's a brief biochemical pathway that I promise not to talk anymore about. Would suffice to say that leucine signals through a protein called mTOR, which is very important in turning on protein synthesis. And we now, through the work of David Sabatini at MIT, have a good mechanistic understanding of how this works. So it's led us to propose what we call the leucine trigger hypothesis, and it goes something like this. You have to consume sufficient protein with sufficient leucine and reach a threshold, if you like, for muscle protein synthesis to be robustly stimulated. So we've got two scenarios here, a low dose and a high dose protein. You can see that the low dose does not meet the threshold and you wouldn't get a good protein synthetic response, but the high dose does. The good news is the trigger moves. So the more active you are, the more work that you do in a given day, and this is physical work, then the trigger goes down. But it only stays down for a short period of time. So the truth is you have to keep being active. You have to do it probably every day. If you are older, if you are immobile or don't move much, if you have a disease like type 2 diabetes, then the trigger goes up. And you either need more protein, or more specifically, you need more leucine to trigger that robust anabolic response. Well, what about the essential amino acid then concentrations of various proteins? How do they compare? And I'm borrowing a figure from a paper written by these three individuals. This is Luc van Loon. He's at Maastricht University, a good friend. Nick Bird is a former PhD student of mine. He's at the University of Illinois. And this is Stefan van Vliet, who was actually Luc's PhD student. And here is Nick's postdoc. What you can see, and this is probably very typical, this is the essential amino acid content of human skeletal muscle. And we're comparing it to traditional animal source proteins, fish, egg, beef, casein from milk. This is actually the milk itself, and this is the whey protein fraction. And as most people will tell you, plant proteins just don't have as many essential amino acids as animal-based proteins, and that is true. However, certain amino acids are considered to be limiting protein or limiting in proteins dependent on their source. And so let's look at some of the more common limiting amino acids. In most grains, the most limiting amino acid is lysine. And in most legumes, the limiting amino acid is methionine. So this is the lysine content. And you can see if we go all the way down here to wheat, it's particularly low. There's rice and oat and hemp, also low. But then when we switch to the methionine concentration of these proteins, they're pretty good. But you can see things like soy and lentils have a particularly low content. And that, of course, leads very well into the notion of what we call protein complementation. And I think, and this always fascinates me, that you travel around the world to regions where a lot of animal protein isn't part of the staple diet. And these individuals will consume beans or a legume of some sort and rice or a grain. So if you're in India, it's lentils and rice. If you're in China, it's some sort of tofu and rice. If you're in the Caribbean, it's red beans and rice. If you're in South America, it's black beans and rice. And that's a tremendous sort of evolutionary signal that people have figured out that these two proteins complement each other. So where am I going with all of this? Well, first of all, grains, of course, are low in lysine. In fact, on a global basis, that is the rate limiting amino acid. It's not necessarily leucine, maybe until you get older. Beans, however, are low in the amino acid methionine. So by pairing or complementing these two sources of proteins, you can see that together, when they're consumed, they have all of the amino acids in good quantities that we need. So what could we do to enhance the quality of certain proteins? First, complementation. That's probably the easiest way to go, and it's the globally recognized important step. Always pair a grain with a legume. We could also add to certain proteins leucine to meet the threshold for the stimulation of muscle protein synthesis. It's not really my first choice because leucine isn't a particularly great tasting amino acid, but it will require a little bit of food science innovation to make that the case. We need to recognize that aging is associated at the muscle level with anabolic resistance. And we know that with aging, through sarcopenia, or the age-related loss of muscle mass, that this is a particularly important condition that affects an older person's mobility and ability to move around their environment. So we need to do something to protect them against this, and protein and physical activity are the two most potent non-pharmacological stimuli. In fact, there is not a single one pharmacological agent or drug that can do this in humans. So we really are relying on lifestyle choices. So one of the take-home messages is older people either need to consume more protein or consume more leucine. So what if we take all of the other stuff out of foods and we just isolate the protein? So again, you see this is Luc Van Loon and his PhD student and a former postdoc of mine, Stefan Gorison. And now we're talking about these are plant-based protein, either isolates or concentrates. So what's happened now is we've processed the food to a certain degree and we've isolated the protein. We've taken out a lot of the anti-nutritional compounds, and we've taken out other constituents like carbohydrates and fats. Interestingly enough, when you look at the percent of essential amino acids as a percent of the protein, here's muscle. You can see that eggs, casein, milk, and everything else is doing a great job. But if you look over here, you can see all of a sudden a few surprises maybe. Look at that, potato protein, and there's corn protein and pea protein. And there are some that go a little bit lower, admittedly, but there are a few plant-based proteins here, the isolates of which seem like a pretty good protein source. And in fact, when you look at the leucine proportion, everything pretty good on the animal side, potato above the threshold, corn above the threshold, pea above the threshold, and so is soy and brown rice. So atypical plant-based proteins that you would think they're lower quality, they're really not that big a deal. But here's the rub. We conducted a study in which the purpose was to establish whether somebody consuming 40 grams of potato protein isolate as two 20-gram doses would stimulate muscle protein synthesis over and above the RDA. It shouldn't if the RDA is sufficient. And so we wanted to establish also whether exercise potentiated this effect. Our hypothesis was that potato protein would stimulate protein synthesis when added to the RDA, and that exercise would stimulate it further. We tested this hypothesis in young women, a very understudied group, and we had 12 participants in each group, and you can see that actually they were pretty well matched for age, body mass, height, and their lean body mass, or their fat and bone-free mass, some of which would have to be muscle. Interestingly enough, and this is all a within-person design with respect to the exercise stimulus, we found that it was only with the potato protein that you got a progressive rise in muscle protein synthesis. So the interaction term here was significant. We actually couldn't detect a significant difference between groups, but when you measure the area under the curve for the potato protein group, it's much greater than the control group. So adding 40 grams of potato protein per day to the diet of these women was able to result in a greater anabolic drive to their muscle. Thought that was interesting, and I was doing a little bit of work for this talk, and then I came upon this article where it says, potato grower starts upcycling unwanted spuds to pioneer high-grade plant potato alternative. And it's true. When we say potatoes, the first thing that comes to mind is not protein. It's a small amount of the potato. In fact, it's only really about 1% of its weight is protein. But we grow billions of tons of potatoes. So these folks said the UK supplier is working on a project to convert unwanted potatoes, in other words, potatoes that didn't have the right shape, that had sort of a little patch of dryness or a little bit of rot on them, for example, and to use them in meat analogs. And this facility processed, I think I've got the number here, 350,000 tons of potatoes a year, about 10% of which were rejected based on shape, size, or something else, some unwanted characteristic that would normally be thrown out. Instead, these potatoes could have the protein from them isolated and be used to feed people or in foodstuffs to bolster the protein content of normally consumed foods. So the take-home points. First of all, potato protein at 2 times 20 gram doses stimulated muscle protein synthesis at rest and in young women in a diet containing the RDA. The exercise increased the muscle protein synthetic response. So potato protein is an effective plant-based protein to augment muscle protein synthesis and potentially support muscle growth. So what is the response chronically? We don't know, but I think it would be important to do that study. And what about in older people? So what are upcycled proteins? Well, here are a few examples from a company that takes food waste and produces a variety of flavors of upcycled protein powders. These are isolated proteins. They taste great. I can vouch for that. And the bottom line is that these protein sources, while they may seemingly be lower quality than the animal-based protein sources, are actually probably much closer to being sufficient, particularly in people consuming a diet otherwise, and being able to support growth or attenuate loss of muscle with age. I'm going to end with showing you a really recent study that got me really excited, that sort of brings the fiber and the protein worlds together. This paper, which was published in Sports Medicine, it was an effort that we put together with a Brazilian group, showing that first, high plant-based proteins versus omnivorous plant or diets resulted in a similar amount of muscle growth. So, as we said in the conclusion, vegans and omnivores had similar anabolic adaptations in response to resistance training. And so a higher protein plant-based diet can easily support muscle anabolism. In other words, it's not that animal proteins are superior. We also I wanted to highlight this interesting paper. When you look at all of the evidence that's out there with respect to plant-based and animal-based proteins and cancer, for example, you can see that a higher intake of total protein was associated with a lower risk of all-cause mortality, and plant protein was associated with a lower risk of all-cause and cardiovascular mortality. So more protein seems to be good, and more plant protein appears to be good. This is a hot off the press paper. And so it came out on the 22nd of June, it's published in Nature Metabolism, and it really challenges the notion that insoluble fiber as a source of protein, and I know that sounds weird, is actually pretty good. And in fact, they fed protein restricted animals high cellulose and high inulin diets, and only the cellulose diet here resulted in the production via the microbiota of sufficient essential amino acids. So insoluble fiber is an important prebiotic. It has the potential for bacteria in the gut to make the amino acids we need, so we don't have to consume them, and that the absorption of amino acids through the colon and not the small intestine, as it usually is probably important. So what can we take home from this? So changes in muscle protein synthesis are the predominant mechanism dictating changes in muscle mass. The main stimuli for muscle protein synthesis is feeding, but that's transient, and loading, which is long lasting. The main driver for muscle protein synthesis and feeding protein is leucine. That's the key amino acid. And so proteins higher in leucine would support greater rates of muscle protein synthesis, both acutely and chronically. Plant source proteins, which are lower in general in essential amino acids and leucine, could be enriched, or they could be complemented to become useful plant proteins, or you could simply eat more. When we talk about isolates and concentrates, they're actually pretty comparable to animal source proteins. And so one of my big points to make is the plant proteins, and I put or upcycled plant proteins, can yield equivalent muscle stimulating properties as animal source proteins. And finally, insoluble dietary fiber may be an important prebiotic to prime the microbiome to allow production of essential amino acids. I want to thank you very much for taking the time, and hopefully I can answer some of your questions at the end of the talk.
Thank you, Stu, so much for your presentation. This was excellent. And I would suggest that we save the questions to the end, if that's all right. We'll leave time for the end to address the questions. But thank you, everyone. And we'll move on to Dr. Edward Deehan's presentation on the fiber side of the story. Thank you. Excellent.
All right, can you see my screen okay?
Yes, perfect.
Perfect.
Thank you.
So thank you, Dr. Phillips or Stu, for actually a really nice segue into my presentation, where I'm tasked with giving the fiber side of the story, how we can add nutritional value through upcycling different agricultural side streams into important dietary fibers. So before I really get into all the different possibilities out there, I just want to take a step back and really take a moment to define what dietary fiber is per the FDA definition or the Codex definition. So dietary fiber are non-digestible carbohydrates that when they're found within plants, so intrinsic and intact within plants, they are any non-digestible carbohydrate as well as lignin is considered a dietary fiber. Now, when you isolate them or you synthesize them, these non-digestible carbohydrates, they're considered a dietary fiber only when they show physiological effects and benefits to human health. So what are these benefits to human health? Well, the very first kind of foundational benefit is really around gut health. So improvement in regularity, laxation, bulking, or dilution of different toxins, but it extends beyond this to really whole body health. We have improvements by reducing the amount of energy density within our foods. Also at the same time, improving satiety, reducing levels of hunger, and improving levels of glycemic control and lipid levels by improving the excretion of different bile acids. And although the changes in the microbiome are not defined underneath the FDA as far as a health benefit, there are beneficial effects on the gut microbiome through the fermentation and utilization of different dietary fibers. Now, what exactly is the microbiome? Well, you can consider it as a highly diverse ecosystem within our gut, within our primarily large intestine. And this ecosystem is kind of like a rainforest. In essence, you have a really dense and highly diverse ecosystem that directly has effects on our overall health. And this overall health extends beyond beneficial effects or effects in the gut health towards mental health and immunity and so on and so forth. And today, consumers are really starting to understand how effects in the gut, how effects on gut health mean effects on overall body wellness. So they extend way beyond what's happening in our small and large intestine. Now, the problem is that people aren't really consuming enough dietary fiber. On average, throughout the world in a lot of developing countries, from the US, Canada, Germany, France, Japan, and so on and so forth, intakes are around 15 to 20, sometimes a little bit higher grams of dietary fiber per day, where recommendations are more around 30 grams a day. And if you take a look at what people are consuming, most of the dietary fiber that meets these levels are being consumed as whole foods. They're provided as whole foods as opposed to using isolated or synthetic fibers to reach these levels. And if you take a step back and look at our ancestral diet, essentially the diet that gut microbiome really evolved, having been fed, and the microbe interactions with our body, whole body health and our immune system, we were consuming over 100 grams of dietary fiber a day, suggesting that the amount of fiber that we're consuming, this fiber gap is a lot bigger than really what we appreciate. And it's easy to understand how this fiber gap, especially when you consider the ancestral diet, how it came to be. And that the amount of the foods that we were consuming, here's a picture of wild bananas, they have been grown to be more palatable, to reduce the amount of fiber within them, and to improve the palatability of the overall product. And this extends to a lot of different fruits and vegetables and grains. And during this change, and in this growing process, we've lost the amount of dietary fiber in these foods. And we've also lost a little bit of the diversity of the foods that are being consumed, overall having an effect on reducing or making it a little harder for us to achieve these dietary fiber levels. So the question lies is, can we actually use synthetic or isolated dietary fibers to lessen this gap? So using added fibers to reduce the amount of this overall fiber gap. And there are a lot of different dietary fibers out there. Dietary fiber itself is a very heterogeneous group. It's important to know that there are some considerations when using these different dietary fibers, or when isolating these different dietary fibers, and that just because you're able to isolate or synthetic and produce a non-digestible dietary or non-digestible carbohydrate does not necessarily mean that it will have a health benefit. And this goes back to the FDA's definition. So you need to be able to show that you have physiological effects to health in order to be able to be considered a dietary fiber on the food label. It's also important to consider the diversity of different foods, of different isolated and synthetic fibers that are on the market is actually quite low. For instance, psyllium, a natural isolated fiber, is used a lot to improve metabolism as well as a functional aid. Resistant starch, resistant maltodextrin, and polydextrose are used as ways to reduce the amount of digestible starch and reduce the amount of digestible sugars within our diet. And lastly, inulin, FOS, GOS are the typical prebiotics that are used, a very limited array of prebiotics used to target the microbiome, which on some end is kind of concerning because of how diverse and how complex our microbiome is and its ability to be targeted with different dietary fibers. And the last product that's used a lot and a lot of available are mixed plant cell wall dietary fibers, which instead of having one specific type, primarily it's a mixture of different types of dietary fibers. So how can we obtain more diverse dietary fiber sources to be used to put into the foods that we're consuming and ideally reduce the fiber gap and improve health of our society? Well, one exciting opportunity is actually different agricultural side streams, and considering really consumers' demands and push for more naturally and sustainably sourced foods and food ingredients, and to have more of a free from additives and functional ingredients. Using these different agricultural side streams is quite promising in the ability to isolate fibers and other ingredients from them. And if you consider all the different foods that are grown across the world, you can see all the diversity and potential that's here to isolate different fibers, from different types of fruits, the pomace or the peels, to different grain cereals, such as corn bran or oat hulls. So the question lies, can we actually extract and purify these dietary fibers from these agricultural residues or waste products that are essentially lost or wasted during production? And this is important considering about up to 12% of our food supply is actually wasted during this agricultural production, so could theoretically be used to isolate fibers and other ingredients. There are a lot of opportunities to be able to achieve this, in that we have improvements in technologies to achieve more targeted extraction, produce these extractions at scale and less cost, to be able to preserve fiber structure, trying to preserve the health benefits and the functionality of our fiber ingredients. And really, from the push of sustainability from consumers and the desire for things to be more sustainable, we have a lot more side streams that are becoming commercially available. And these several opportunities that really are contributing to the success of AgriFiber within this field. So at AgriFiber, we use our patented extraction and purification technologies to allow us to upcycle agricultural side streams into purified fibers at scale and at a lower cost. This allows us to offer clean label fibers for both health benefits and product functionality. And here are our current fiber portfolio. And our portfolio really started with focusing on corn bran and the fibers that we can isolate from them. So we've isolated an insoluble, highly functional mixed plant cell wall dietary fiber that's primary cellulose and arbenoxylin, and a soluble fiber that is a prebiotic and a functional fiber that is primarily arbenoxylin, which are MSC and BFG respectively. So from there, we've branched off and have focused on oat hulls, achieving and obtaining an insoluble MFO product, and are working on providing and obtaining a soluble arbenoxylin that's slightly different functionally to the BFG from the soluble corn bran fiber. And we don't really want to stop there. We want to expand beyond and looking at a lot of other agricultural residues that can potentially be used as functional and health promoting fibers. Now it's important to note that the functionality, the health benefits of dietary fibers are all linked to the fiber structure. So differences in source, sugar type, linkage type, chain length, particle size, all affect the fiber structure. And changes in the fiber structure affect how the fiber can modulate the microbiome, how it affects symptoms, the production of gas and negative symptoms associated with fiber intake, how it can affect different health benefits and what benefits are contributed to that health or to that dietary fiber. And lastly, how it can affect food and beverage formulations. So during the isolation process, it's important to note that isolating itself, depending on the method used, can affect the structure, and these alter the effects. So at AgriFiber, we really aim to conserve this natural structure that is found in dietary fibers. For instance, our AgriFiber BFG, which is a purified arbenoxylin, we try and conserve that complex dietary fiber structure in the arbenoxylin backbone and branching network. For instance, trying to maintain the high levels of ferulic acid that are found naturally in corn bran. So actually what I found during my PhD, we took AgriFiber BFG and we had asked people to consume it for 6 weeks. Females, they consume 25 grams per day of dietary fiber as BFG, and males 35 grams. We found that after consuming it, we saw very specific enrichments of a bacteria called Bifidobacterium longum, which is a very well-studied probiotic commonly provided that has been linked to benefits from gut health to mental health and all the way a lot around immune health and allergies, improvements in allergies. So the idea is that the complexity of this arbenoxylin, our corn bran, soluble corn bran fiber, allowed for highly specific microbiota stimulation or modulation, which really lays the foundation for our essentially a novel next generation prebiotic for more targeted effects on select bacteria that are health beneficial, such as Bifidobacterium longum, and opens the door for development of synergistic symbiotics or pairing our dietary fiber, our AgriFiber BFG, with Bifidobacterium longum for very targeted health beneficial effects. In addition to this, we found that the symptoms were actually, over the course of the period, were one, we saw some mild to moderate increases, but they're very mild compared when you put it in the scope of inulin or FOS and other oligosaccharides, where even feeding close to 15 grams per day are considered not tolerated very well and contribute to a lot of symptoms. We also found that over the course of the 6 weeks, the symptoms essentially disappeared, and by the end of the 6 weeks, there were no difference in symptoms compared to the baseline. So this gives the idea that this complex dietary fiber reduces the rate of fermentation, reduces the rate of gases that are produced, which on one hand helps promote the fermentation along the GI tract as opposed to very proximal in the GI tract, which has several benefits, promoting beneficial bacteria along the GI tract. as well as reducing the overall symptoms and improving general GI tolerance of complex dietary fibers like agrofiber BFG. In the study, we also saw that individuals consuming the dietary fiber after 6 weeks saw a significant increase in their level of perceived satiety after consuming the fiber compared to cellulose. And this was maintained across the intervention period. In addition, we saw improvements in insulin resistance, fasting levels of insulin, and its extrapolation of home IR of levels of insulin resistance. And these results are actually quite in line with the literature out there. In particular, we see in Europe, there's an FCA claim around wheat endosperm extracted arabinoxylans for significant improvements in postprandial glycemic response. So confirming the link between consuming arabinoxylans and improvements in glycemia. So this is really important to consider, especially when you consider the structure of the arabinoxylans. So both corn bran and the wheat endosperm arabinoxylans, which are more longer chain and moderately viscous, show beneficial effects on glycemia. However, when you chop them up and you reduce the chain length and reduce their viscosity and produce arabinoxylan oligosaccharides, you can tend to essentially lose these beneficial effects on glycemic control, or at least reduce the consistency in the effects that you see. So in addition to the health benefits of dietary fiber, there's a lot of product functionality and that is highly dependent on the fiber structure. And there's the functionality of dietary fibers is actually quite diverse, contributing to effects on gelling, thickening, stabilizing, binding, emulsification, ability to help control moisture, influence oil absorption within the product, and also adding to the overall nutritional value of the product. And a lot of these dietary fibers or non-digestible carbohydrates, because not all of them are considered dietary fibers per the FDA, are within the groups of gums or mucilagids, or are chemically synthesized carbohydrates like modified celluloses to add functionality to our products. So the question is can we actually use upcycled, purified dietary fibers? And should they be really explored as an alternative, functional, clean labels ingredients, as opposed to more chemically synthesized and less desirable dietary fibers or non-digestible carbohydrates? And for this, I want to just discuss a little bit about the effects of our agrofiber products on stabilization and emulsification, as well as their ability to add to the nutritional value of foods. So first, we find that using both of our agrofiber MFC and BFG, we have the ability to replace emulsifiers in confectionaries and baked goods, preventing blooms of sugar and fat by decreasing interfacial tensions. We also see that emulsifiers like lecithin have actually been shown to disrupt the gut barrier, promoting inflammation. They've also been linked to be metabolized by the microbiome into TMA, which can be produced TMAO and contributed or at least linked to the development of heart disease and type 2 diabetes. And soy is also considered a common food allergy. So being able to reduce emulsifiers within these foods is considered a health beneficial attribute. I've also been shown to replace emulsifiers and stabilizers in different animal and plant-based foods and beverages, stabilizing the dispersion of isolated proteins and protein shakes, holding oil in burgers and plant-based alternatives to improve yield, texture, and juiciness, and as well as being able to produce certain less desirable functional ingredients such as carrageenan, which have been shown as well to disrupt the gut barrier function, potentially contributing to inflammation. In addition to this, we can use our dietary fibers to improve nutritional FACSM panel, reducing the amount of calories, decreasing the level of fats, and potentially helping reduce the level of sugar within foods. In addition, we can increase the level of dietary fiber within foods, and this is just an example of how we can use agrofiber BFG as a prebiotic ingredient within granola bars to increase the amount of dietary fiber above a good source of dietary fiber levels. This is very relevant for plant-based alternatives, as well as low-carb keto-friendly foods, which are very much in trend for consumers. However, these foods are considered to be often less in dietary fiber, although they have great potential to be added, dietary fibers added to them. In addition, we can blend our dietary fibers with other fibers and provide more of a complete dietary fiber source of insoluble and soluble fibers and prebiotic ingredients. So with this, there's a tremendous potential to use these different sources and isolate proteins. Of course, we have the same kind of opportunities there, using technology to target and extract different isolated proteins at scale and with less cost, and ability to understand the protein quality and push for more sustainable ingredients by using these side streams that are available. And with that, I just want to leave with one final idea, in that we can bundle dietary fibers with proteins, and that, due to their own individual effects on health, may help improve satiety, reduce hunger, improve and promote muscle mass over fat mass, increasing energy expenditure, improving glycemic control and cholesterol levels. Dietary fiber can also on its own help reduce calories and improve glycemic index, and can counteract the negative effects that may be observed by dietary proteins within the gastrointestinal tract, improving regulatory and reducing harmful protein fermentation. In addition, bundling, although this is an area of that needs further exploration, bundling dietary fibers with proteins may also help improve and have synergistic effects on functionality within foods, improving emulsification, solubility, binding, foam formation, texture, and moisture control. And a nice example of this is the fact that within the plant cell wall, dietary fibers, different fiber sources are bundled within and with soluble proteins to have an overall functional effect within the plant cell wall. And with that, a couple of take-home messages, in that there's really a need to consider other fiber sources and structures for health and prebiotic benefits, and produce functional product functionality to overall reduce the fiber gap. That residual agricultural materials offer exciting opportunity for the development of novel and sustainable fibers and protein-based ingredients. Bundling upcycled fibers and proteins may promote synergistic effects on health and product functionality. And with that, I would love to open the floor for any questions.
Thank you so much. Wonderful, Edward. Thank you so much. We are almost out of time, though, unfortunately, but I want to thank the panelists for their time and exceptionally good presentations. I think our traditional ways of formulating for health have changed, and with the appearance of these interesting new sources of upcycled ingredients, we have a real impact to make both on our planet and health, clearly. So looking forward to seeing a lot of more products with upcycled ingredients. Thank you so much. I appreciate your help for today. And I do have a quick question, though. I see here we had one from Adelia on, I'm sorry, too. Here, does co-extrusion of fibers and proteins, as in the production of high moisture extrudates and texturized vegetable proteins for meat analogs, have a known impact on any of the parameters you mentioned that are important for human health? This goes to Edward, I believe. Dr. Deehan?
So from my knowledge, I'm not sure if there's any work or what work has been done on that to know how they would have an effect. I think overall they're both on their own very beneficial. So combining them, whether through extrusion or through other methods, has a lot of potential to have a synergistic effect, and a lot more research needs to be done on this, using isolated fibers and proteins as opposed to within providing it as a food itself. But it's definitely a possibility, and it's likely that they would have tremendous effects on the microbiome and health as a whole.
Okay. All right. With that, thank you so much. I don't see any other additional questions. Must be a very clear talks for sure, and I appreciate everyone's time. For more information, please feel free to reach out either to either one of these panelists or AgriFiber Solutions as well, which is website I will post now as well. Thank you so much. Enjoy the rest of your day and appreciate your time. Thank you. Thank you, everyone. Thank you, panelists as well. Thank you, Dr. Deehan.
Thank you, Stu.
And Stu. Thank you. Bye.
Bye-bye. Take care.
Bye.